Good evening, everyone. Myself, Neeraj Ranakoti. I am Research Associate in AIMS Rishikesh, and I am moderating today's session. So, first of all, I warmly welcome you all on hands-on workshop on Statistic Made Easy, Basic to Advanced Online SPSS Series Season 2. The topic to be covered today are displaying on your screens. Without further delay, I would like to invite Dr. Ashok to kindly begin the session. Over to you, sir.
Thank you, sir. Thank you. Good evening to all participants. So I am sharing it's day 4. Okay. So today we will discuss about again descriptive. Descriptive means mean, mode, median, interquartile range, standard deviation, minimum, maximum, frequency percentage. And then inferential statistics. Inferential statistics, number 1 is parametric test and number 2 is non-parametric test. Okay, I'm opening my slide. So Neeraj sir, my slide are visible?
Yes, sir. Visible, sir.
Okay, thank you. So in parametric test, when dependent variable, that is a quantitative data is normally distributed, then we have to use parametric test. If not normally distributed, we have to apply non-parametric test. So like this, we have to calculate mean and SD if that quantitative variable is normally distributed, and median and interquartile range when that variable is not normally distributed. Minimum and maximum is for both of these things. For mean and SD, we should calculate minimum and maximum, and for median and interquartile range we should calculate minimum and maximum also. Frequency and percentage for qualitative or categorical data. Okay, so we have discussed this slide yesterday. Okay, so these are examples of what is independent and dependent variables. So example 1 is effect of diet and yoga on hemoglobin, because hemoglobin level is dependent on diet and yoga. So hemoglobin is dependent variable, diet and yoga is independent variable. Same as effect of diversion therapy on PAN level or PAN score. So PAN is dependent on diversion therapy. It means it is a dependent variable, and diversion therapy is a independent variable. And effect of this SPSS workshop on knowledge and practice of statistics. So because knowledge and practice of statistics, okay, depend on SPSS workshop. So knowledge and practice is dependent variable, and SPSS is workshop is independent variable. And this is a very famous slide, and please remember this: parametric and non-parametric test when we have to use. So today we will discuss about two dependent groups. If there are two dependent groups, okay, categorical variable, there are two categories: male, female, intervention and control group. Okay, we can say dead and alive group, whatever. There are two independent group, and if our dependent variable is quantitative, for example age, for example score, for example hemoglobin in this case, okay, and parametric, if that quantitative variable is normally distributed, we should go for parametric test, that is an independent or unpaired test. If it is not, then we have to go for Mann-Whitney U test. like is for same group before and after, pre and post, before pain level, one group, single group, 100 patients, for example, and we have to assess pain level before, then we have to give diversion therapy, and after diversion therapy, we have to assess pain of those same patients. Okay, so the like pain score is a quantitative variable. It is normally distributed. We can go for PAT test. If it's not normally distributed, we have to go for Wilcoxon signed rank test. If more than two groups, okay, for example, group 1 control, group 2 treatment A, and group third is treatment B. Okay, there are three groups, more than two groups, and dependent variable is quantitative, for example, hemoglobin, systolic BP, creatinine, whatever. If this quantitative variable is normally distributed, we should go for one-way ANOVA, otherwise Kruskal-Wallis test. And about quantitative and Pearson and Spearman, we will discuss tomorrow. So I leave it. And also for repeated measure ANOVA, we will discuss tomorrow. So this is mnemonic, and I have discussed yesterday about this mnemonic. I do play with REMA. Okay, I means independent t-test, D means dependent t-test, O means one-way ANOVA, P means Pearson correlation, and REMA means repeated measures ANOVA for parametric. But counterpart of this parametric is we can remember using this mnemonic, that is a Mawali kahin ka sirfira, we can see here, or Mr. Wilcoxon kindly see fried rice. So this is like Mawali Man Whitney U test, M Mawali Wilcoxon, that is a that is a Wilcoxon signed rank test. Kruskal-Wallis, that is a Kahika, and for Spearman correlation, that is a S, and then Friedman, that is a Fira F. Okay, and here, Mr. Wilcoxon, kindly see fried rice. Okay, so sorry. Okay, so this is we can say, if dependent variable, sometimes if you think, if your guide and co-guide think, if reviewer think that if a dependent variable is ordinal number, for example, NRS span scale 0 to 10, okay, there is no decimals between, or modified Rankin scale, okay, this is the disability scale, also later. Sometimes there's no need to check normalcy. Directly go for non-parametric test and calculate median and interquartile range. Okay, nowadays I think it's fashion to calculate median and interquartile range if there is data is no ordinal number, mild, moderate, severe, no pain, mild pain, moderate pain, severe pain, something like that. So this is NRS score 0 to 10, and this is a score 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there is no decimal. We can go for directly median and interquartile range and can use a non-parametric test. If you use parametric test, it's okay, no problem, but reviewer comment may come and then you can change it. Okay. Then this is a modified Rankin scale, MRS, it's called MRS, and this is 0 to 6 scale. Okay, and GCS score also, Glasgow Coma scale score, that is also. So 0 means no symptom to 6 is dead. Okay, no symptoms, mild, like no significant disability, slightly disability, moderate disability, moderate to severe disability, and dead. So it is an ordinal number. 0 is no symptoms, 6 is dead, and there is no in between decimals over there. And not 1.2, 1.5, 2.2, 2.5. It is called ordinal. So we can go directly for non-parametric test, apply non-parametric test, and do median and like interquartile range, and we can compare. Okay. So let's have fun with SPSS. We will do today descriptive statistics, and after that parametric and non-parametric test also. Okay. So this is we have discussed yesterday also. repeat just. So randomized control trial to assess the effect of diet and yoga on hemoglobin level of cardiac patients. I have sent Excel sheet to you for this exercise, and primary objective to assess the effect of diet and yoga on hemoglobin level of cardiac patients. Secondary to assess the effect of diet and yoga, that is an intervention, on LDL and HDL level, and to assess the effect of diet and yoga on patients' survival, mortality. Okay, and we selected 300 patients randomly, 100 in each group, and did 1 month or 3 months follow, whatever. And it is a between group and within group analysis. Between group means between two groups, control and experiment. Within group means within intervention group or within control group. Within baseline, if you want to like assess difference from baseline to third month, baseline to 6 months, third month to 6 months, it's called within. Between means like between intervention and control group, between three groups, among three groups, that is between group and within group analysis we will do. Okay, so let's start, not wasting time. Okay, so first I should see my Excel sheet, and it must be follow 7 rules. So this is my Excel sheet I have sent you. It is yesterday's Excel sheet. There is no major changes. There is no changes. Okay. So I have to see, okay, first column is serial number and first row is variable name. I should see all the things. And how many patients? There is 300. Okay, very good. Okay, it's fine. And where is my data? Data is in sheet 1. You can see like left side lower. Okay, there is a sheet 1, sheet 2, and sheet 3. My data in sheet 1, not sheet 2 and not sheet 3, only sheet 1. So when I import this Excel sheet into SPSS, then I should select this sheet 1, not sheet 2 and sheet 3. Please remember this. Okay, I can cross it. Then I have already opened this SPSS. So second method I prefer. Okay, so please you can click this restore down nearby this cross button. You can see my cursor. Click here. Okay, it's looking very good. Then I have already opened this SPSS. So I think I'm not wasting time today because it will take time. So I have to again click this restore. Again, click this restore down here. You can see right side corner, cross, minimize, and this. Then I make double screen it. Okay. I have to arrange according to this. Very good. Then what I have to do, I have to click this practice sheet or whatever sheet I want to import. I have to click and then drag to in this area of a SPSS. That is a move. You can see here move. It is looking okay. And I leave my like finger from pad. Okay, touch pad. Then it's coming. Very good. Read Excel file. And as I told you that my data in sheet 1, you can see this is a worksheet here. If you click here, there are 3 sheet 2, sheet 3. So my data in sheet 1. Okay. And then I told you that must be click this. I'll always click 3 things. Okay. And click OK. So my data is importing from Excel to SPSS. It will take some time, no issue. Okay, it's opened. Very good. Then I first I can see, okay, how many data entry here. There is no extra entry. Okay, there are you can see here from 301 to 305 there are some extra dot. Okay, so what I have to do, I have to remove first. Okay, so I have to click this 301, then shift and down arrow, and then I bring my cursor here in this area, right click and clear. Okay, now it's okay. Now first I'll calculate descriptive frequency first, then we'll go for parametric and non-parametric test today. Okay, so for mean, median, standard deviation, minimum, maximum, these are for quantitative variables. Okay, so what I have to do, please click this analysis button This is very famous button, analyze, okay. Then click this descriptive statistics, then frequency, okay, you can see here frequency. Then this frequency dialog box will come. You can increase or decrease size. You can see my cursor. Then when I bring this cursor, this corner, you can then drag it, okay. Then click on age, okay, age, and click here, and then you can drag it from here to here. You can drag. Then only duration of illness. I'll show about for 2 only duration of illness. Then drag from here to here in variable view. Then click on statistics. You can click here. These are the statistic chart format style bootstrap. Click statistics. Then you can click percentile value, quartile, okay, median and interquartiles. You can click on central tendency, mean, median. You can click on dispersion, standard deviation. You can click on minimum. You can click on maximum. Okay, it's okay, no issue. No need to like click other things. Okay, then continue. Then if you want chart, okay, you can click chart. And then you want, for example, histogram, then you can click histogram and then show normal curve on histogram. If there are categorical variable, for example, male and female, okay, then you can click bar chart and pie chart. Also, like next, when I have time about this, you can just click continue. And as I told you that there is no need of this frequency, display frequency table for this mean, median, standard deviation and interquartile range, something like that. So suppose if I, okay, if I like keep it, okay, I'll keep it, okay, as it is, okay, then click okay. So what happen, you can see here. So output is coming. You can see here it's a like age and duration of illness, you can see, and then it's a valid N and missing data, you can see here. Then mean, both mean, median, standard deviation, minimum, maximum, you can see here. And then you can see this is a percentile, 25th percentile, 50 and 75th percentile. 25th percentile is a first quartile, that is Q1. Okay, 50th percentile is a Q2 middle quartile. Okay, and it is equal to median. So you can see median is 57.00, 50th is also percentile is 57.00. Okay, and then 75th is a third quartile. Okay, so it's called from 40, you can see 46 to 62, that is your interquartile range, Q1 to Q3, and this is a median. 57 is median. And you can see frequency table, because I did not like click or de-check that display frequency table. So this is frequency table you got. Yesterday you did not got this, but did not get this, but today you got it, because I remained, click that tick over there. You can see here, and duration of illness, and this is, you can see histogram for age and histogram for duration of illness. Okay, so for other variable you can calculate. Then I want to do independent t-test first. So for this, what I have to do, because I have to remember that for independent t-test, there must be two group. Okay, there must be two group for independent t-test. It may be experiment or control, whatever you want to calculate between control or experiment, or male or female, or mortality or alive, but it must be two groups. And dependent variable, your quantitative variable. It may be age, it may be creatinine level, it may be duration of illness, it may be like creatinine level, it may be HDL level, it may be LDL level. But for independent t-test, you must have two group, not more than two. If more than two, it will go, for that we have to apply one way ANOVA if dependent variable is normally distributed. Otherwise, we have to go for Kruskal-Wallis test. Like if there are two groups, our dependent variable is normally distributed, so we have to apply dependent or unpaired t-test. Otherwise, we have to go for Mann-Whitney U-test. So for how to apply t-test in SPSS, okay. So click analyze here, then go for compare means or proportion. In less than 20, 30 version, I think you can get only compare means. There is no proportion. Please remember this. So click compare means over there. If you have 30 version, then compare means and proportion. Okay. Then go here, independent sample test. Okay. It's very simple. Then click this. You will get this dialog box. You can see, okay. It's, I think, very big. Okay. No issue. So this is dialog box you can get after clicking that tab. Then I told you in test variable, you have to enter your dependent variable. So I want to do comparison of age, okay, between two groups. It may be male or female, it may be other, whatever, okay. It may be hypertension, yes, no, there must be two groups. So what I have to do, I have to click this age. I bring this age in test variable. So click here, okay, and whatever two groups, that is a independent two groups, you have to enter in grouping variable here, okay. So I want to compare age between gender, okay. This is a sex. I have to click this. Then I have to click, not here, you have to click in grouping variable. So quantitative variable in test variable and grouping variable in group in grouping variable, okay. Then I have to click this define group here, okay. So I have to click define group. And what like coding I have given, I should remember that, okay. So for gender, I have given coding 0 and 1. I remembered it, okay, 0 and 1. So please click, like type 0 in group 1 and in group 2 type 1 here. Then continue, okay. Then click OK. No need to do anything here. Just click OK, okay. Then you will get this window or this output, okay. You will get this. You can see here, this is age, its age mean and standard deviation. You can see here, these are the number of, and as I like told you that 0 is for female and 1 is for male. I can decode it. Yesterday we have decoded it. So again, because today I imported from like Excel to SPSS, so I should have like again coded it, okay. I should, but I didn't code it, so it's coming like 0 and 1. I can code it, no problem, but I know that 0, what is 0 and what is 1. So it's a n is equal to 77, and here in 0 it means female, and in male it's a 170. This is mean and this is standard deviation I can get here, okay, because we need mean and SD. Then where is we have to see this independent sample test, and here is Leven's test for equality of variance. We should see this. This is Leven's test F value. This is SIG is P value for this Leven's test, okay. Then this is T value. This is degree of freedom, we can see here, and this is a two-sided P. Always we should take two-sided P, not one-sided P, okay. Two-sided P we should take. So this is 0.034. It means it is less than 0.05. It means there is a significant difference in age between male and female. That is my conclusion, okay. So it is a less than 0.05. And one thing more, you have to see this, what p value I have to take. I have to take this equal variance assumed p value, or I should take equal variance assumed not p value. there are some difference between two p-values. So how I choose this, how I judge it? So I have to see this Leven's test for equality of variance. If this the SIG, that is a p-value for this Leven's test, if this Leven's test p-value is greater than 0.05, please remember, please listen. If this Leven's test for equality of variance p-value is greater than 0.05, then we should go for equal variance assumed p-value. Okay. And if this Leven's test for equality of variance is less than 0.05, less than 0.05, then we should go for equal variance not assumed p-value, and this is coming 0.048. In this case, it is greater than 0.05 because it is 0.071. It is greater than 0.05. So I should take this p-value 0.034. Okay. So this is main thing we have to look in independent t-test. Okay. This is a mean difference between male and female. This is a 95% confidence interval of mean difference. This is a lower bound. This is a upper bound. And what is 95% confidence interval? We will discuss later. So this is a lower band and this is a upper bound. We can see. Okay. And this is also effect size, Cohen's d effect size we can take. Like in 25 or below 30, I think there is no this effect size. So this is value of the effect size. We can see here, this is the value of effect size and this is a lower bound or upper bound. If you get, you can report it. Otherwise, there is no need to report it. So below 30, I think you will get only this table, group statistics and independent sample t-test value. So how to take this mean and SD, you can see here. And this p-value of always take two-sided p-value. Please don't take this one-sided p-value. Okay. So and which p-value we have to take? We say it is depend on this Leven's test of for equality of variance. It is if this p-value is greater than 0.05, we should go for this equal variance assumed p-value. Okay. And if it is less than 0.05, we should go for equal variance not assumed p-value. Here it is greater than 0.05, so we should take 0.048. This is p-value of this comparison between a male and female of age variable. Okay, we can say there is a significant difference of age between male and female. And what we can see here, female age is 57.78 and male age is 54.55. So in our data, the females older by 3 years. Okay, mean. Okay, mean 3 years. So we can see there is a mean difference here. So older than males by 3 years average. Okay, so this is a t-test. Now we have to go for, this is a t-test, we have to go for now paired t-test. So in paired t-test, as I told you, dependent or paired t-test, there is a before and after situation. So I have to see my data, where is before and after situation, then we apply t-test. Okay. So what I have to do, I have to click this star button below analyze, or I can click in taskbar. There is a untitled 2. You can see here, and I should see my data first. And when I see my data, you can see here that is a hemoglobin. Okay, hemoglobin. This is hemoglobin. Okay, hemoglobin pre-intervention and hemoglobin post-intervention. It is a pre and post phenomena or design. So I can use, if I want to calculate difference between pre-hemoglobin and post-hemoglobin, then I should go for paired t-test if both pre-hemoglobin and post-hemoglobin are normally distributed. Okay, if both pre-hemoglobin and post-hemoglobin are normally distributed, I should go for paired t-test. Otherwise, I should go for Wilcoxon signed rank test. Okay, let's do it. So click analyze. It is very famous button. Click analyze here. Then click compare means again. Compare means and proportion. And this is a paired sample t-test. So please click this paired sample t-test here. Okay. So this dialog box will come. You can see here paired sample t-test. This is a pair, variable 1 and variable 2. This is a pre and post, whatever. Okay. Then what you have to do, you have to go for that HB. So this is, you can click here, you can drag this up and down, and you can stop over there where is pre-HB and post-HB is over there. So please click this first pre-HB here. Okay, click here. We should bring this pre-HB in variable 1. So what we have to do, we have to click this and then click this horizontal arrow right side. Okay, click this. It came here. HB pre, you can see here. Then click on post HB. Okay, then click on post HB and then click this arrow. It came here. Okay, and no need to do anything in this. No need to do anything in this. Just click OK. It's very simple. So click OK. Then you will get this. Okay, it's very good. You can see here, it's a paired sample statistics. Okay, and above one is a independent sample test. So this is a difference. Okay, so in paired sample, this is a pair one. Pair one means HB pre and post, there is a pair. Okay, pre and post, there is a pair. Mean is 12.83 and in post 12.95. This is a 300 and 300. This is standard deviation. You can see here 1.7713, 1.82. You can see here. No need of this standard error mean. There is no need. This and then this is correlation. We will discuss correlation later on. So leave it. And this is main p-value table. You can see paired sample test. And here is, this is p-value. There is a significance. And I think in less than 30, there is only SIG here, two-tailed, something like that written over there. So you take two-sided p-value, two-tailed or two-sided p-value. Please always take this. Leave this one-sided p-value. Leave it only two-sided p-value. Two-sided p-value means there is a difference. Okay, it may be like pre is like I can say mean value of pre-HB is high, okay, or like post-HB is high, no matter. But there is a difference over there. But if we choose one-sided p-value, it means we have given some direction. Means pre is less than post. We have given direction. So we choose this one-sided p-value. But in two-sided, it may be like high or it may be low. So in health research, we are preferring this two-sided p-value, and it is not coming significant. So we can say pre and post HB mean average are comparable. There is no significant difference. And this is a mean difference, you can see. Okay, pre minus post, this is a mean difference. We can calculate post minus pre, and we can calculate pre minus post according to your what you want to do. Okay, this is a standard deviation of the difference, and this is a leave it standard mean error mean. You can leave it. There is no need of this. And this is 95% confidence interval of the mean, lower bound and upper bound. This is a t value. This is a degree of freedom. So what is degree of freedom? In this case, it is n minus 1. In paired case, paired sample t-test, it is n minus 1. So how many samples here? Here 300. So 300 minus 1, it is coming 299. But when we see here, like in degree of freedom in independent sample t-test, it is n1 minus 1 plus n2 minus 1. n1 minus 1 bracket plus n2 minus 1. And please calculate. This is n1 and this is n2. So n1 minus 1 plus n2 minus 1. And please calculate this degree of freedom, and it should be come 245. Please check your this formula and you will get it. Okay. And this is also you can get here Cohen's d. It is a point estimate. It is a const d value, and it's a 95% confidence interval. And as I told you that below 30, I think you will not get this Cohen d. You will get only this with a two-sided p-value, not a one-sided p-value. So please take that. That is a standard. Okay. So you just remember it is a pre and post, before and after. Okay. Now go for one-way ANOVA. As I told you, one-way ANOVA is for there are more than two groups. So I have to again see my Excel sheet. Okay. And so this is below analyze. I can click here, analyze, and I can do analysis. There is no problem. Okay. Otherwise, I can go in data and can do. Both are similar way. Click here, go to data. This is data. And I'll see that I want to compare these control group. There is a control group. This is diet group, and this is a diet and yoga group. There are three groups. Okay, it's very good. So there are three groups, and I want to compare these three groups like hemoglobin between these three groups. So pre-hemoglobin I will compare first, and post-hemoglobin I will compare later. So how do this? So I have to click again because there are more than two groups, and it is a categorical variable. This is an independent sample. So it I suppose that I checked normalcy of HB pre and HB post, and these are assume these are normally distributed. So I go for one-way ANOVA. Okay. So click analyze again, then click compare mean and proportion, and this is one-way ANOVA. So every button, every test you can find here of mean comparison. Okay. For mean comparison, you can find here. So click one-way ANOVA, analysis of variance. Please click. This dialog box will come. Okay, very good. Then where is my group? Okay, where is group? There is no group in this data. What happened? Oh, in this, there is no group. So as I told you, it is essential to do coding in SPSS. It is essential to coding in SPSS. You can see here in this box, this is a scale type of variable. You can see these are like three balloon, small balloon, but none of the variable where three balloon and A is written. That is a string variable. But when I see here, this is a group is having string variable. You can see here A. So due to this, it is not coming here. So first we have to remove this A. So how can I remove? I must code this group variable. So how can I code it? Okay, let's explain. Okay, let's have fun with this. So please cross it. Simple way of doing this. Okay, simple way of doing this. Please click this sex here. Please click here. Then right click. Then insert variable. This is insert variable. Okay, right click. There is insert variable. Click insert variable. This came here. Okay, this column inserted here. You can see here. So I can give control is group of 1. Okay, remember control is group 1. You can write down in any paper, in Excel sheet. Okay, so click here 1. I give code 1. Then click here, I can give code 1. Then click here, I can give code 1. But it will take time because we don't have time. So what I have to do, click any one here, click here, then Control C. Control C means copy. Okay, copy it, and then shift and down arrow press, and please bring it till control group. Oh, it's diet group came. So continue pressing shift. Please press upper arrow. You can upper arrow. Oh, it's above. Then continue press shift and down arrow. Okay. Then click control V. One, we have given code 1 to control group. Like here, click diet group, give 2 number, then click down arrow. Okay. Then 2 number, then click down arrow. It will take time. So what I have to do, I have to click here and then control C, then shift and down arrow. Okay. Then if it's okay, yeah, it's like I think covering diet and yoga group also. So then shift continue and upper arrow and upper arrow. Okay, okay, yes. Then control V. Okay. Then I have given diet group as 2 coded. Now diet and yoga group, give third group. Okay. Then down arrow. Then copy this third, click here, then control and C and shift and down arrow. Then I can give, okay, this is down, this is up arrow, this is down arrow, this is up arrow. Okay. So control V. Oh, very good. Oh, data. I have given code, I have coded it. Then what I have to do, I have to click this variable 1 because this is variable 1, but I should give group. It is a group. I have coded it. So what I have to do, either I have to double click here, or I have to go to variable view. Same thing. So click double click here. It came. Okay. Then I can give group here. So write down group here. GROUP group. Oh, sorry. I have to remove it. So what I have to do, bring wide this. Okay. I just type group here. Okay. Click here. Then backspace, remove it. Then group GROUP. Okay. Then it's okay. What happened? Oh, it's not coming like. This variable name duplicates an existing variable. There is duplicate. Why duplicate? It means there is already a group variable. Yes, this is group variable. So if you want to click OK, and if you want to give this like group code again, so you have to give some different name. Okay, so write down here. I can give it a GROUP group underscore code. So I can remember I have given, I have coded it. Okay. Then click anywhere. Now I can go for analysis. I can go for analysis from this variable view also. There is a analyze button. Click analyze button. Then compare means. Then one way ANOVA. Okay. This is one way ANOVA. Click here. One way ANOVA. Then this group code came here. You can see here. So I want to compare. Okay, I want to compare age between. So I can click age, and in dependent list, I must bring this age here. Okay. Then I want to compare pre and post HB or duration of illness, because I know that duration of illness is not normally distributed. Although I want to compare in one way ANOVA, I want to compare mean and SD, I can bring this dependent variable illness, duration of illness in this dependent variable. There is no problem. Okay. Then I can compare where is my pre and post HB. Okay, this is my pre HB, and I can click here, and then I can bring this, I can drag this from here to here. Then post HB, I can drag this from here to here, select and drag. And in factor, I have to click this group code. Okay, then I have to click this, and I click this arrow, click here, this group code will come here. Then what I have to do, I have to click this contrast, post hoc, option, and bootstrap. Bootstrap, there is no need of this bootstrap for us. And please click this contrast. There is no need to do anything in contrast. So please leave it. Okay, continue. No need to do anything. Click post hoc comparison. It is essential. Okay, it is very important. So if there are equal variance assumed, or if there is equal variance not assumed, so we have to take this, okay, post hoc analysis. So most famous post hoc analysis, Bonferroni analysis. I will explain between equal variance or equal variance not assumed. Okay, after that. So click Bonferroni. It is most important. I think you have seen in like research papers, Bonferroni correction, Bonferroni correction. It is a Bonferroni correction or Tucky correction. Okay, Tucky and Bonferroni most popular. You can see in SIDAC and Shefe also, but this Bonferroni is most popular. Okay, then click continue. Then click option. Then you have to click descriptive statistics and homogeneity of variance test. Please do it. Okay. If you want to click mean plot, you can click here. No issue. This is, I can click. Okay. I need this descriptive, homogeneity of variance test and mean plot. There is no need to do any other things. Okay. Then click continue. Then click OK. Okay. So what you have to do, you have to like drag or you have to take or bring this dependent variable, quantitative dependent variable in this dependent list and your grouping variable in factor list. And you have to click in post hoc. There is a Bonferroni correction. You can click also Tucky and Shida, but there is no need of this. Bonferroni is very famous. Everybody knows. So click continue. In option, you have to always click descriptive, homogeneity of variance and mean plot if you want, and then click continue and then click OK. So you can see here. Oh, it's very good. So please see this. In age, duration of illness, pre-HB and post-HB. This is group 1, group 2 and group 3. And what is group 1, group 2, group 3? We can also decode because we have coded it. Okay, 1, 2, 3, but we didn't decode it. So please like give or decode this variable. Okay, what is 1, what is 2, what is 3, we should know. Okay, 1 is control group, 2 is diet group, 3 is yoga and diet group. This is n is number in n is number 87 in control group, 92 in you can see here in diet group, and this is diet and yoga group 87. This is a mean of age. This is the standard deviation of age. There is no need of other things. If you want to report 95% confidence interval, you can report it, upper bound and lower bound. If you want to report minimum, maximum, you can report it, no issue. Okay. Then like duration of illness, you can see here. Pre-HB, you can see this is a mean, this is a standard deviation, this is upper bound and lower bound of this 95% confidence interval of mean. This is a minimum and this is a maximum. Okay, like HB also. Then you have to see this test of homogeneity of variance. So what you have to see? You have to see this. If this is a test p-value of this Leven's statistics, as we have discussed in independent t-test, Leven's statistics, and as I told you that if it is greater than 0.05, it means we have to take equal variance assumed. And Bonferroni is a like test of equal variance assumed. If there is a equal variance assumed, we should use Bonferroni. Otherwise, we have to use another test. So Bonferroni is very famous, we should use. So we can see none of the one we should use all like based on mean also. Okay, there is no need to use median and trimmed mean. There is no need of this. Always use for based on mean. Okay, so this is also greater than, this is also greater than. So it means we can say the variance among the group for age, duration of illness, pre-age and post-age are normally equally, approximately equal, comparable. We can say comparable. There is no difference. Okay, so it's called equal variance assumed. Now it is like ANOVA one-way analysis. We can see here this is always we should see this SIG significant. This is a p value. So should go for age, it is p value is 0.951. There is no significant difference among groups. Duration of illness, there is no significant difference among groups. You can see p value 0.568. Pre-HB pre, it is 0.816. There is no significant difference according to group, and HB post, there is a no significant difference. So using this analysis of variance, we can see among group, there is no significant difference. Okay. So our diet therapy or diet or yoga therapy is not so much effective in like HB, comparison of the HB. We can conclude it, okay? Because this is a hypothetical data, so no need to worry. Okay, but and we can, there is no need of this sum of square, degree of freedom, mean square, and F. If you want to report F, degree of freedom, and P value, you can report. This is a F value. This is a degree of freedom. But please remember, in ANOVA, you have to report degree of freedom of between group and within group, both 2 and comma 263. You have to report this. Okay. So for all, you can get this degree of freedom F value. This is a ANOVA value. Okay. F value means F statistics. It is a ANOVA value, and this is P value. We can, there is no need of this effect size. If you want to present effect size also, you can use this eta squared. It is very famous, eta squared. In this, you can, there is no difference. Point estimate, there is no difference. You can see zero estimate. So these are the, because these are not significant, so it's coming like this. Otherwise, if there is a significant difference, you can get it 0.5, 0.7, 0.8, 2.3 if there is a like significant difference, and you can get it's a 95% confidence interval also. And this is very like beautiful test. It is called post hoc test for multiple comparison. And we should use this test when our ANOVA test is coming significant. If it's coming non-significant, so there is no need of this. But I want to see how to interpret it. Okay. So this ANOVA is p-value. This ANOVA p-value is there is a significant difference at least between two groups. And which two groups, we don't know. But this ANOVA value say there is a difference between any two groups, maybe control and yoga, control and diet, or maybe between control and diet and yoga, and maybe diet versus diet and yoga. We cannot say. So for this, we can say if from here p value is coming significant, so we can say there is a significant difference between any two group, at least any two group. It may be a significant difference between control and diet, and control and diet and yoga, and diet and diet and yoga. But this is hypothesis of ANOVA test, at least between two groups. Okay, any two groups. So if it came significant here, then we should go for this multiple comparison, and using this comparison we can say, and this is p value here, we can say here in age, this is group 1, that is a control group. This is group 2, that is a diet group, and this is a 3 group, that is a diet and yoga group. And this is a p value of between control and diet group. This is 1.0, because it's a hypothetical data. I'll show tomorrow in non-parametric test, I'll take some significant data, then I'll show this. Okay. And this is 1 p value, 1.000, and this is, you can see here, this is control group, and this is a diet and yoga group, and there is a this is a comparison between control and diet group. You can see this is a mean difference, and this is a standard error, and this is p-value for control and diet and yoga group. You can see here again, this is diet group, 2 is diet group, 1 is control group, and this is p-value. We have already seen this 1 versus 2 or 2 versus 1, same thing, there is no need to. Okay, and this is 2 versus 3. 2 means diet group, this is 3 is diet and yoga group, and there is no significant difference here in age, you can see. So you have to see according to this in age also, and this we can see here there is some different, like there is some change in p-value here. So we can see HB post, this is control group, this is diet group, and we can see this is p-value 0.597. okay, this is control group and this is diet and yoga group, it's coming 0.283. okay, close to significant. Yeah, then this is control group, diet group, this is control group, again same p-value 0.975, because 1 versus 2, yeah, 2 versus 1, same thing you will get. But here 2 versus 3, 2 means there is a diet group, this is a control and diet and yoga group, this is third diet and yoga group, this is p-value 1. So we can see here, and this is 3 versus 1, 3 means this is a diet and yoga group, and this is 1 is a control group, this p-value is 0.283. it is also not coming significant. Okay, and this is a mean difference, this is a standard error, and this is a 95% confidence interval mean difference you can report. And this is a mean plot of all. This is a group 1 2 3 means control, diet and yoga, and this is a mean of age. You can see here age is increasing but not, because the not significantly. Okay, there is no significant difference. You can see in a duration of illness also you can see, and these are the graph. So I think I should finish it because it's already 7, and we can do tomorrow about non-parametric test, because we are, I think, one day behind the our schedule lecture. I think one day, but no issue, we will complete that. So if you have any question, you can ask. Okay. So if I want to code this 1 2 3 group code, so I'll show you. I'll show this. So what I have to do, I have to click this data view here from here. Then this is a group code. Okay, it's like a variable view. It's a variable view, group code, and this is values. So I can go from here to here, click here in front of group code, and below this value, I can click here. Then I can give in value, please write down, please click plus. But I think in below 30, there is no need to plus. The values and label are visible. So in value, please click 1, and label, you can click label control. Then click 8, 2, you can click here diet group, diet, and click again. Third, we have given diet and yoga. Below 30, you have to add. Every time you have to click add. 1, you have to click in value 1, then label control, then you have to click add. And again, you have to click 2 in value, and then in label, you have to type diet. Again, you have to click add. And again, you have to, in value, you have to write third, and in label diet and yoga, and again you have to click add button, and then you have to click OK. So I have decoded it. It's called decode. Okay, then so I have, and then again I have to save this output. So what I have to do, I have to click this, this below transfer, there is export button. I have to click this. Then I please go for all visible. Okay, And then I can like here I can click here, name change, otherwise yesterday was replaced, so I click here, I can give name is 2 3 whatever 224. Okay, then I click OK here, then it will take some time. Yesterday one participant asked that if I want to save only 1 and 2 table, then how can I import it? I don't want to export all the result. Okay, it's very lengthy, but I want 1 and 2. So for example, I want to save this ANOVA. Okay, so click this. Okay, then click this. 1 minute, click this, control, then click this. Okay, so I think one by one, so please click this. Okay, ANOVA table, and this is also 1 minute, control, I have to see this first. Okay, click this descriptive ANOVA, then go in below transfer, there is a export button, and click this selected, then you can select, you can save only this. Okay, otherwise I prefer please save all visible, and then you can it is saved in export, sorry, so saved in Word file, then you can delete from over there, no issue. So click OK, because already I have given result 24, so it came like it is already like exist. Do you want to replace it? Okay, I can replace it, no issue. If I don't want to replace, click OK, no, then cross it. This is data sheet. Again, please import this data into Excel sheet. Okay, from SPSS to Excel. So what you have to do, you have to click this file button. You can see untitled to, click file button. If you want to save this, you can click this save button here. Then this is SPSS session. You can give name of this C24, whatever you want to give name, you can give, and then click save. You can see here there is a change as C24. And if you want to export this data from SPSS to Excel, so what you have to do, click file. Okay, then you have to click this save as button. Please remember, save as, no save, no import data, no anything. You have to click save as. Click file, click save as, click save as here, then this will come here. Okay, this is SPSS session, SPSS 24. I have just saved it. Then please click this save as type here. Please click this here. Okay, please bring your cursor here and then click. Then you have to bring scroll down this and this is Excel 2007 higher. We should save in this file, in this format. Okay, click here. Then we have to give, okay, sheet name, it's okay, no issue. File name and sheet name I can give here. Then click here, that is a, please see here, write variable name to file. Variable name, you want to only names or label. So there is no need, you can click on names here, no issue. You can click labels, no issue, leave it. Save values label were defined instead of data value. It means we have given label. Group 1 is equal to control, group 2 is equal to diet. So diet is label. So, and 1 and 2 is data value. So you want to save label or data, it's up to you. So just click save, no issue. Okay, then click this save. It's running. Okay, I can see here it's in this is sheet 24. You can see in my SPSS session, it is saved in Excel. So I can open it, I can see it, no issue. Okay, so this is saved. And why null is coming? Because these are empty in SPSS. So these are coming null. I can remove it. I'll remove tomorrow. It's like a small thing. I can remove null, 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 no issue. Okay. So I have saved my Excel sheet in this. Okay, thank you. So I think we have left with the non-parametric. Okay, no issue, we can do. Okay, thank you.